Hello there. Welcome to the stream. All right, let me get a few things situated, and then we're going to get right into working on the Macintosh Analog SE board. My name is James. You might know me as Bald Engineer. In this stream, we are going to be working on something we call the Bit Preserve project. Let's see if the bot is alive. This is a project where we recreate schematics in KiCad for vintage computers. And since it is Marcintosh during the month of March, we'll be working on a Macintosh. Now, we tried to do the SE schematic last week, and I'll show you why we're not working on it today. But what main reason I want to work on the analog board is because I believe the analog board in the Macintosh SE and SE30 is the same, and I have both of those in my lab that I'm recapping, and so I could really use the schematic. And so, yeah, that's why I decided I'm going to go with, we're just going to go with that one today. All right. Almost there, almost there. Okay, cool. So, link in chat if you're curious about Bit Preserve. It's basically what do you call that thing where you put GitHub? It's a GitHub repo. And then we do have a channel dedicated to it in the Adoms Discord server, which you could join if you'd like. As a streamer and content creator, I am legally required to have a Discord so that we can have the same. Never mind. I'll just stop there. I've got to remember to disable the overlay, but we'll do that another time. All right. So, I shouldn't have come here yet. Let me distract you with, if you didn't know, there is a new Adoms video. It dropped yesterday. Look at me using language like the video dropped. Anyway, it is on the Apple II. Specifically, I used the Mega 2, or my version of the Mega 2 computer, to demonstrate why or how to measure the stretch cycle of the Apple II clocking system. The real issue I had is to really demonstrate that you have to understand the video system, and I didn't want to get into explaining the video system yet. And so I feel like when I do explain the video system, it's just going to be like I'm going to end up repeating the clock again. But I kind of wanted to give that kind of topic a try for two reasons. One, because I wanted to show an oscilloscope that was sent to me in a way that was more interesting than just talking about the scope's features. And then the other thing is I just wanted to give kind of the format of that. I just wanted to give that format a try. So anyway, so here's the deal. Last week we tried to redraw this schematic, and I just want to point out that this is not a streaming artifact. This is what the schematic looks like. What occurred to me while I was enjoying tea after last week's stream, I eventually had tea. I'll bet a bunch of this is the same on the SE30 and the SE, because I think there's a lot of commonality in their design. And so I think the approach we might take is for the logic board, I'll probably go and work on the SE30, which has better schematics, and then maybe we can backport that to what this one is for the SE. But like I said earlier, I'm being selfish. I need the analog board, which is basically where the CRT plugs into, and the power supply. But the power supply is not as, I want to do the power supply next, but I want to get this analog board done because I feel like this is where I will want, anytime I deal with something that has high voltages, I want the schematic, because I want to be able to look at it and say, is this something I really want to be messing with? Or if I mess with this, what might happen? So let's do this. Let's create a new project. We'll call this one Macintosh SE Analog Board. Macintosh SE Analog Board. Create a folder. We'll come in here, and then we will just hit save. Actually, I just want to do just a couple of things, because basically I want to be able to commit this into what's that thing called? I already forgot the name again. That's the wrong window. It's page setup. I just want to do revision 1, and then I'm just going to say vol.e/bitpreserve. That's not where that goes. I'm going to put at Bald Engineer because I'm the one doing it. And then this will be the Macintosh SE analog board. And let's go ahead and just make this bigger now. Okay, we'll save that. And then the other thing I want to do is let's go to the symbol editor. And we're going to create a symbol library. I like having symbol libraries for each system and component. Even though starting with KiCad 6, symbol libraries, individual symbol libraries for a project aren't nearly as critical, especially in something like this, because the symbols get stored as part of the schematic now. Version 5 and before, there was a copy in the schematic, but it was linked to the library. It was kind of a mess. Anyway, where I'm going, even though it sort of isn't necessary anymore, I still like the idea because, like, if say I want to, if we find out that the SE30 does have a different analog board, then I want to be able to reuse the symbols without having to drag everything else. So, all right, so we'll just do Macintosh SE analog board symbols. There we go. That looks good to me. And then we'll save that. And then that's where we're going to get started. There's a couple of ICs in here that we're going to go ahead and just create the symbols for. And then for a lot of the other stuff, we'll just use the standard library components. But like this one right here, item number 1. I think this is let's see, where's the new symbol? I think this is a TDA 1170N. I'm not positive about that, but we'll check that here in just a second. And then I'll hit save. Okay, I want to do all of that. So now I can come over to my Git tool and say, I want to take all of the analog board stuff and stage that. Oh, this is going to be fun. And I'm in the Mac SE branch. We'll just stay there. I don't want to, well, we're going to stay there now. I should have created a new branch. Initial create for SE analog board. Oh well. This is why I solder for a living and I don't use Git. Even though I use Git every day. Yeah, silly guy. All right, so let's come over here, minimize that. Now we're going to do a search for TDA 1170A and see if we can find something that describes it. This looks promising. I don't know who this website is. But low noise, TV, deflection, yep, all those words sound like things that matter to us. So let's go projects, farts. I don't want these in the bit preserve, Mac SE data. I'm just gonna put it up here for now. I just want to have a local copy of the data sheet in case something happens. We will put this link, since it's the one we found, let's put that into the properties. And then I'm just going to say for the description, this is a low noise TV vertical deflection system. Yeah, that looks good. All right. Okay, save that. So now so one of the reasons I want the datasheet is because I'm going to copy the symbol as it is in the schematic, but I'll want to use the datasheet to verify what types of pins everything is. And so this one since this is kind of an analog chip, that was funny sounding. So none of these have names, so that's frustrating. So let's do 2, 5. Nope. Okay, that's fine. 3. I'll come back and fix that one in a second. 4, rotate. And then down here, we'll do 11. Do I have the overlay on? Yeah, I do. Okay, good. Good. So if anyone has watched the recent Adams video from yesterday, there was one thing, I did it in the KiCad video, and it was mostly because of time, but I didn't include any music, background music in the video. There's the intro noise or music. I just call it intro noise for some reason. And then I added a little bit of a little jingle thing at the very end, just because I really like having, like, on the end card, I like having something there. But I couldn't. Part of the problem is I couldn't find any music tracks that I like, because the stuff that I used to use, which I would just relicense, I can't license anymore, or I have to relicense it, and I don't want to pay the relicensing fee. And so part of the reason I put no music is I just couldn't find anything I liked. But I also just kind of felt like in a explainer video like that one, I almost felt like I didn't need it. So yeah. Okay, you know what we're going to do here is I'm just going to call it tab. Nope, still not big enough. Okay, so I don't like changing the pen length, because then it's going to want to change for everything, but I'll just have to remember to change it back if we do anything. There, that way we get this little tabs thing. All right, so then this pen we need to fix because I accidentally did the pen name instead of the number. So we'll just use the property manager. Oh, by the way, I think I'm using KiCad 801 release candidate 2. Or is 801 released? Maybe 801 got released. Now I don't remember. I did report last week. I think last week I was using the release candidate. I did report that the copy paste bug that I found had been fixed, and I can confirm that that is not the case. I just did it wrong. So that's kind of a bummer. I was really hoping there was a change related to copy and paste, and I was kind of hoping like whatever I found, it was getting caused by that, but it doesn't look like it. All right, so now let's go to the data sheet. All right, so now we have pin names. So one is ramp output. I'm just gonna say ramp out, because like, yep, that's gonna be a problem. 10 is amp in. And then let's see, 11 is comp or compensation. Not a pin where you get paid. 4 is PA out, power amplifier out. 9 is the oscillator. Let's do that. And then 5 is the power amp supply voltage. Really? You know what I'm just going to call this? I'm just going to call this PAVCC. Let's see. What are we missing? Number 2 is VCC. And number 5 is... Wait a minute. How can I have a 5 here? Okay, I messed up. PAVCC. I'm going to do this on purpose because I want to show something. 3 is flyback. All right. Now we're going to extend the bottom of our symbol, even though I recently unextended it. Now we're going to move this down. And then in 12, this is the ramp generator. Number 7 is the height adjust. I'm just going to call it HHDJ. And number 8 is sync in. I'll bet that's the sync pulse, which I talk about in the most recent Adams video. I'm laughing because I have a video coming up where I keep repeating something over and over because I'm making a point. And it's like now I'm being really self-conscious of every time I repeat myself. All right, where'd you go? Over here. So what was 6? 6 is a regulated output. All right. All right, so that sounds like this is actually a power output. We'll do a no connect in the actual schematic. Ramp output sounds like it is a output. Let's see, where did ground go? And these two are power inputs. Remember, power inputs are for devices. So most devices will have power input for both the VCC and ground pin. This one is a little bit different because it looks like it has a built-in regulator. So it has an output because it looks like it creates a regulated voltage. What's my thought on the new KiCad? I like it. I think 8.00 was a little more unstable than the releases for 6 and 7. I kind of feel like if I had to guess, and this is just me talking, I'm not judging, I feel like the team might have pushed a little too hard to get the we want an annual release, and so I feel like they may have released 8.00 a little too soon, because it seems like there was a lot of stability issues that a ton of fixes went into 8.01, which is great. I mean, that's sort of the trade-off, right? It's like, okay, I mean, even if the very first release wasn't all that stable, but it's like I almost feel like 8.00 was release candidate 3, and 8.001 is the real first version to use. But overall, I like it. I did do a video of, I said 8 things I liked in KiCad 8, but there's 2 things I realized. Well, first is I actually talk about 11 features, but not all of them are KiCad 8 features. And I also made a big deal about the fact that teardrop support was added to PCB, and I completely missed that teardrops was actually a version 7 feature, or at least it was in 7. I don't have anything newer or older installed, and it's just that they consolidated how you create teardrops. But I totally thought it was a new feature, and I was wrong. I was wrong. All right, so 2 is input, 3 is a, I wonder if 3 looks like an input as well, doesn't it? Yeah. I wonder if it's a power, no. And then 5 is a, yep, yeah, so 3 is definitely an input. It might actually be a power input, but I'm not sure. Do they have a pin description? That's what I should really be looking at. No. But 3 definitely, to me, looks like a, it actually looks like a power input. I'm not going to make it a power input because we're going to get a flag. So let's see. 4 is definitely output. 11 is, let's see, what was the name actual? It's compensation. So it's probably an input. And then let's see, amp in, number 10 is a preamplifier. Looks like it gets regulated. I wonder, where's all this stuff coming from? Because 1, what's the name of 10? Oh, it's an amp. Okay, so that's the input, amp input. Let's see, pin 1 is ramp out. Okay, I think I see what they're doing there. 12 looks like a supply pin. What do we got? Where's 12 at? Ramp generator. All right, that sounds like an output to me. Interesting. Let's see, 7 is likely an input. It's probably like, it probably generates a voltage, and then yeah, it's probably, it generates a voltage and then measures whatever the drop across the thing is. So it's actually, now that I say that, it's actually an output. I'm actually going to call this one passive because I'm not clear. It's a little less clear. 8 should be an input. Where'd 8 go? It's down here, and then 9 looks to me like that's the input for the or no, that'd be the output of the oscillator. Nope. It's the input. Okay, cool. Let's change the color of this with the background body color, save, and then move on. All right, so that is in good shape. What else is on this schematic? There was a MC or MP part that I remember. Or it's like an MC32 something, I think. Ugh, we're gonna have to draw transformers. They're always more than meets the eye. Ooh, that's what I should add. Is a little drum thing. Okay, let's zoom out. I'm missing the part that I'm looking for. Oh, I know why. I'm thinking of the power supply. Okay. I am not going to draw this power supply thing down here because I don't think that matters. We're going to draw the we'll draw the connector. I'm not drawing this power supply assembly. We'll just put a note in there or a box or something. We don't need a symbol for that. Yeah. See, this is what caught my attention, is this schematic is on the site that I found it on. It was in the SE directory, but it's written SE30. But then, like I said, I sort of thought about it, and it's like, well, the analog board for the display is probably the same between the two. The SE30 is essentially an upgraded SE. And so I don't think the power supply might be different. And like the upgrade is like the floppy drive, I think, is one of the big differences. I don't know if it's a different processor. I thought it was, but I read something real quick earlier today that made me think otherwise. So, okay, we'll close that. And now we can go back to the KiCad. And let's see where we're going to start. Do we want to start with that chip, or is there something better to start with? I'm thinking let's start with the IC, just because we've drawn it, and then that way we can kind of finalize this section. It's got a bunch of easy stuff around it. So let's do this, and then let me shrink up. Aw, come on, Windows. When doesn't. Haha, see what I did there? I'm good. I made a funny. All right, let's move this over here. So let's see. Doesn't really matter where we put this. Let's go ahead and do an add. That might take a second because I have to load the footprint still. Load. There we go. All right, so what are we looking for? A TDA? Was that the name of the thing? Yep, TDA 1170N. That seems small. Basically, it looks very small. Okay. I did just realize I made a mistake. You know what I should do? I just realized I should write a script that swaps the default window values based on my screen resolution, so that when I switch between streaming and not streaming, it's a lot easier on me because I have to always move everything around. It just occurred to me I could probably do something that handles that. Because like even when because the other problem I have is when I do screen captures, I have to basically do everything twice. At least I have to do everything in KiCad at least the first thing I do or record, I have to do at least twice because I have to keep moving all the windows around. It's very frustrating. Let's do update symbol, update close. Then now it should have a value. It does not. Why doesn't it have a value? Edit library symbol. It has a value here. Did I not say show? I said show. Okay. Let's save that. Let's try update symbol one more time. Update selected symbol with that one. Oh, I forgot to say using this. There we go. Nope. What the heck? What the heck? Update symbol from library. Oh, I have to tell it value. So update from library value. That makes sense. Okay, there we go. All right. Finally, it's doing what I want. All right, we'll make this a U2, not the band. Nope. There we go. And then we'll just kind of do that. All right. So up here, we need a C polarized small. Basically, it's very small. And then over, let's see, is there any others? Not that I see, obviously. Or not anything that's obvious. Oh, I just realized I stitched this together bad. Maybe we're going to go, we might go fix that real quick because that's going to get annoying very quickly. Okay. Let's see now. Now we need a C small, non-polarized, and we'll put that like roughly here. And then we need a D filled, nope, D small filled, yeah. And we'll put one of those there. And then we need a plus 12 volts, which can come up here. It's going to go roughly there. All right, so this is C1, and it has a value of, okay, I see what they did. It's probably 100 nano, and it has it's 50 volts. So let's do voltage, 50V. I'm going to call it, I'm actually going to change this to rated voltage. I'll turn on that, and I'm going to put that down here. All right, this diode is CR1, and it has a value of 1, or is it IN or 1N? Looks like a 4001. So it'd be a 1N. I'm going to go with 1N. All right. And then this capacitor will be C2. And we're looking at, that's probably 100 microfarads. And just like the other one, it has a rated voltage. So let's go ahead and add that. We'll do a 16 voltages, and we'll put this down here. Now I'm thinking what we'll do is I'm gonna leave that up here. Oh, that should be a 100 U. I used E that time instead of the property manager just because I'm used to hitting the hotkey. There's really no advantage in one way or the other. Hey, Francois. Welcome to the stream. Good to see you. Hope you had a good day and a long evening, I would imagine. All right, 5 is coming up to here, and that's going to go over to there. Ooh, it would be nice if I could space this out just a bit more. I think we're going to do that. So let's do this. Let's try something. We're going to do edit library symbol. I'm going to move any mountain. Oh, nope, wrong thing. We're going to move this. I want to move these pins. Just kind of move them out here. I'm going to move this to here. We're going to move this to probably about here. Basically, I'm going to play a little game. Okay. So if we did that large, we can move 5 back. And that will be in a good spot. And then 2 can come over at least 2. So let's save that. Update this. I just realized there's actually a better way to do this. Hold on. I'm going to close this. If we do edit symbol, this will edit the copy of the symbol. So I was doing edit symbol in library, Edit symbol edits the symbol in the schematic. It's not connected to the library. But the reason I want this is now when I save, it will automatically update in the schematic. So it's a little bit faster to do this fine tuning. All right. Save that, because that's about where I want that, because then I can move this over. That looks pretty good. And then if I have these two connect, and I have this come up, I'm using G to try and drag that over. That looks pretty good. All right, so now I can come and move this. Looks like 1, 2, 3, maybe that many. Yeah. Maybe one. Okay, so now what I'm just going to look for is, let's see what it's going to take to center the part, which means we got to move our schematic, the other components, but that's okay. It's not the end of the world. There we go. So now I can move. Oh, I'm going to left. I'm going to right. I'm going to drag to the right to only get the pins. I don't want any of these text fields. All right, so we'll save that. I'm going to minimize because we're probably going to move stuff around in a second. So left dragging. So remember, there's two ways to drag and select. Right or dragging to the right. Anything that fits entirely inside of the bounding box gets selected. But if you drag to the left, anything that touches the bounding box gets selected. So like here, all of the component, all three of those components, all the wires, and then the 3 value labels are going to get selected. Although I guess those got selected because we selected the part, right? Yeah, okay. Here, this is a better one. Now the 12 volt will get selected. But if I drew the same box this way, the 12 volt and the wires will not get selected. See, no select, no select, no select, no select. Anyway, and that concludes our how KiCad does selection demo, which is not unique to KiCad. FYI. All right, 50 volts, and then we'll need a ground symbol. Trying to get a Sony Bravia TV to play video from DLNA. Yeah. So are you trying to like play with like whatever its built-in OS is, or did you use some kind of external box? Okay, so I'm looking at this, and I can see this is going to get confusing down here. I'm going to give this a real quick shot. I want to try and see if we can't fix this. Oh, that's not what I wanted to load. Shoot. Shoot. Shoot, 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 shoot. Shoot, shoot. Open recent analog board GIF 1 and open recent. I'll show my screen in just a second. All right. Okay. And then I can go and close this real quick. All right, so I'm going to do an image, canvas size. We'll extend it this way by, I don't know how many pixels this is. What's 30 times 70? 500 pixels. 500 inches. Yeah, that's a little much. Let's do a ruler and go to pixels. And so this is, how wide is this? 2,500 pixels. Holy cow. All right, I did not realize. I guess I could have just done this. I could just do this. Say %, and do 100. That'll make it twice as wide. I'm going to copy and paste this into here. And that's how I messed up earlier. So then if I just do something like this, and let's see, will it let me, I'll just say, okay. Like, yeah, will you let me change the opacity? All right, I'm going to do a deselect. Wait, that's not what I wanted. That's not what I wanted. What are you doing? What are you doing? What is going on? Oh, I know what's going on. Image mode. Let's go RGB. So I'll do a new layer, paste, and then I wanted to do it this way because I want to make its opacity to be like 50%. So I can see where this lines up. Like, because this is totally what I should have done earlier. I just didn't realize it wasn't a clean split. All right. And then the rest of this, yeah, it looks way better. All right, so let's take the opacity back up. All right, well, zoom out. That is actually just slightly off. I can see it. There, I might have actually hit that by mistake. Okay, that is so much cleaner. Let's do an image trim. Bottom right. And then let's flatten and do another export. All the things, huh? That sucks. Hey, RJ Helms. Fancy meeting you here. It's good to see you. Let's see. This is analog 1 and 2 combined. I'm going to save that. I'm going to replace it. Now we're going to close this because Photoshop, we don't need Photoshop for what we're doing. I wish I could just right click and say reload. Oh well. I can probably just do open this, and this should be the updated version. And it is. Okay, that's much cleaner. Cool. All right, now we can get back to work. Yeah. So the power output, we're going to add a resistor, which we haven't done yet. So we'll do an R small. So all of the devices, I think all of the devices in the device library have a small variant, which I prefer. They fit much nicer into schematics. So I want to see if I need to move these pins. It looks like I do. I'm going to move PA out up at least 1 or 2. So we'll go back to our symbol editor, and I'm going to try and move this up to there. And then let's see if I drag this wire up here and then do one of these. We're still off by 1. Just trying to make things look nice. There we go. Hopefully that works out. So what I'm going to do is once we're done filling in around, I'm going to go back and save that symbol back into the library. Since saving the schematic version automatically updates, it just saves us a little bit of time. All right, so now we need a non-polarized capacitor. I can make this a little smaller. Yeah, you don't trust people that don't use small symbols. Yeah, yeah. I remember. I fondly remember drawing the 2GS schematic, and our friend Geek Bozu was in the chat, and he kept yelling at me about using. He's like, use the other one, use the other one, use the other one, and I'm like, why? What difference does it make? And I was so glad I finally listened and used the small version, because the small version of the passive symbols allows you to just get so much more to fit onto a page. You know, it's just like, yeah, that's the only one to use. The other thing I do is in my library, so like I think everybody should have a custom library, which would be fun to actually ask people what they call theirs. Mine is affectionately called My Library. So in my library, I have 805 and maybe 0603, and if not, I'm going to soon. I have passive the small variants of resistors and capacitors with 0805 footprints already assigned to them, since that's the most common that I had been using. I'm actually transitioning to 0603, and as I get to a point where I'm going to start using assembly services, I'm going to get down to 0402s, because I can rework an 0402. I can hand solder an 0402. I just don't like to. There's my bug. Did you see it? Did you see it? I clicked on the symbol and it reverted. Oh, how frustrating. And it doesn't always go back to the question mark. It goes back to whatever it was before. Oh, come on. Okay, I got to remember. So I'm just going to close the property manager because it's broken. Unfortunately, it is just not usable in this context because every time I use it, it forgets what see, like we lost all of these symbols. For those that aren't following, I'll try to demonstrate it right now. So if I take this resistor and I copy and paste it, see how it reverted back to R question mark. That only happens if I edit. So if I open the property manager back up and I edit this to be R1, I don't know, I'm just picking a random number. Now if I copy this symbol and paste it, it disappears. But if I hit E to edit the reference field, and then I'm going to put 222 just to make that point, I should be able to copy and paste this now with no problem. See? So this stayed. So it's something about setting the value via the property manager causes it to revert when you copy and paste the symbol. It's very frustrating when you're doing something like this task. Yeah, it is. It's probably how you learned about them too. Geek Bozu complaining. Yeah, I kind of feel like that's one of those things where it's like, I mean, there's nothing wrong with using the big symbol. It's just that once you find out that, oh, this other one exists, it's like, oh yeah, that makes my schematics look way nicer. And it's a super easy thing, you know, it's just one of those little tips that's like, yeah, I'd rather use that. All right, so now we need another polarized cap, which looks like it's the same value as that one, so that's nice. I'm gonna put that right about here. So my hope is between this week and next week, we'll get the analog board and the power supply for the SC done. And then what I probably will do is in April, we'll go back and finish the MC10 since we're almost done with that one. I think mostly what we have to do on that one is run ERC and clean it up. But I wanted to spend March on Macintosh stuff. So we'll come back to that later. All right. So now, is this R10? That's interesting. When I look on that screen, okay, so it must be a scaling thing. Okay. Because my OBS is showing that to look very weird. Okay, I got to close that again because I keep using it. All right. Edit 5K6. Okay, so this will be, so wait, no. We need a polarized, nope, that's not polarized. 10 nanofarad capacitor right about here with a ground, probably somewhere around here. And that's going to be C6. And that is easily 110, 1 nanofarad. That's a weird value. And 50 voltages. Okay. So the 10 pin goes well below all of this stuff. Well, that's crazy. I dramatically undersized this symbol. All right, so let's go back to our symbol. And for the moment, I'm just going to do like a ridiculous, actually, let's move the pins first. I'm just going to move them like way down here. It doesn't really matter. I'm going to try to guess. I could probably count this out, but I think we're just going to do this. Save. Oh, almost. Save. Okay, so we got that. I'm going to put these back here for now. Oh my God. Oh my God, this is hilarious. I'm going to read this out loud. So I just got a Facebook Messenger post, which is, I'll do it on my phone so I can mark it as spam. But it's like, it says, hey, I saw you liked person you know's post regarding going solar. Is the no-cost solar program something you're interested in getting more information on? So there's a couple of problems with this. Number one, I didn't. Well, actually, the only problem with it, I never liked anything related to solar because I don't use Facebook. The only thing I use Facebook for is to post what I'm doing on Atoms and Bald Engineer. Oh, goodness. Let's go. Sorry, I'm going to spam, submit report, and block. Sure, whatever. Just block. Why is there more than one block option? If I want to block somebody, block. Anyway, well, that was fun. Back to our regularly scheduled program. Okay, so 10 comes out. It comes up to there. I'm going to bring this down just a little bit. Make that a little nicer. Let's see. Where does this go? Okay, this goes to a port. I'm kind of backing up a little bit. Let's go and finish drawing out the rest of this node. So we'll do R12. Oh, come on. That's getting really frustrating. That was 9. So 12. R12. This will be 4.7. This is some kind of current sense, I guess. And let's add, let's do power. 0.5 watt. Oh, forgot to say show. And then we'll, if I hit O, does that line everything up? Let's try it. So I select the symbol. Nope. If I select the symbol, okay. I'm going to press and hold. I want to select the symbol and then press O. Yeah, look at that. That's nice. O basically resets the auto positioning of fields. I don't think that's new. I think that's been around for a while, but it's new to me. Is it frustrating because you have nodes? Ha 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 ha. You're so funny. No, you're not. That's one of the interns. Debatable if it's a good one or bad one. All right. However, they do bring the good intern, so there's that aspect. All right, 1,000. I just realized what I did. I'm not going to say if they're the good one or bad one. And then clearly identified. Oh, good times. Okay, so we need these we need this off page or this off board port. What was the schematic, last schematic where I created that? What was the we were doing? Shoot. I have an idea. We go to youtube.com/addons. Oh crap, it's going to say something to us. Where did I have... It wasn't the MC10. What did we do before the MC10? We did... Oh, you know what it is? I think it was in the Apple IIe. Yeah, I think it was in one of the power supplies. So what I want to do is let's go open up... Actually, it won't be in the recent. Open project. Let's go retro. Nope. It'll be under bit preserve. Bit preserve. Hey, SPET, welcome to the stream. So what were we doing with the Apple IIe power supply? Yeah, this was the one. Okay, so what's going to be the easiest way to do this? Actually, I didn't. Okay, so now that I remember what we want to do, I'm going to go to the schematic editor or the symbol editor. We're going to add a library. to the project. And then I'm going to, and this is actually exactly why I still want individual libraries for each schematic, because it's easier to get to the symbols for the Apple IIe power supply since they're all in a library. We don't have to go open up the schematic and deal with that that stuff. Because in here, what I want is con off board, and I think I want the single, right? Yep. So we're just going to do this. I'm going to say save a copy as, and then I'm going to put this into the SE analog board symbols. All right. And then we're going to close that library. Wait. Save that one. Yes. Okay. And then let's go get rid of that library before I forget. We'll just delete that. Okay. Is this in my repo? Yeah. Well, it's in the BitPreserve repo, which I pinned up top. There's, I don't know, maybe 24 computers. I should actually count because I don't know. I know it's, I think it's more than 10. I know, well, here's where I'm at. I think it's more than 10 and probably less than 100. I know it's well below 100. Board. Here we go. But it's facing the wrong way. Okay. All right, that's fine. We're going to do edit library symbol. I'm just going to change it. And let's see, how's this look? So I'm going to delete this one, and then I'm going to rotate this and rotate this. And then we're going to move them both. That looks good. And then on the pin, I'm going to make this 100 mils. And then can I move this to about there? And then these, if we move them back, I think my graphic override, maybe if I do in to 10 mils and then do move there. That's what we're looking for. Okay, I've got to, now that I did all that, I'm going to move this over to there. And then we're just going to make this pin longer. Uh, 200 maybe? Oh, I see what's going on. Actually, 150 is probably fine. There we go. Okay, I am going to make it 200. Actually, if your question was if I manage this repo, then I would say yes. I'm the owner of the BitPreserve repo. I'm just careful to say that it's mine because lots of people contribute to it, and I don't want to miss their contributions. All right, there we go. Oh, you know what? Okay, yeah, we're just gonna have to do. Why can't I edit? What the heck? I can't edit the symbol. I'm gonna try putting it back in here. Okay, that, with version 8, you can click on pins now. And so it thought I was clicking on the pin instead of the symbol. That's what happened. Because I wanted to delete the pin number, which then actually means I can make this shorter again. That's what happened. So I'll explain. Let me update this before I forget. So what was happening is I'm clicking on this. It's actually selecting the pin, which if I hit edit, doesn't do anything. The reason you can do that is because now if you right click on a pin, there are things called pin helpers available to automatically populate things like wires and net labels. And so the alternative is because I needed to click on like the graphic element, and that's kind of hard. What I could have done is I could have just click and held, I think. All right. Yeah. Yeah. Okay. This symbol's funny because it's small. Whatever. Okay. Oh, cool. I'm glad it's helping. All right. Let's come down to, let's see. So that gets us to out of here. And then down here, 56 or 56K, 47K. Let's try this. And let's go edit 4K7. We're going to move this down here. And we're going to make this be 11. Move this down here. And then we're going to copy this resistor since it has the power on it already. And this roughly goes right here. So let's middle mouse button to drag everything. And then we'll do R13. 1 ohm. That is not adding many ohms. Put this over to here, put this to here. And then we're going to copy and paste a ground symbol. I kind of wish some days, I wish there was I wonder if you can do it now that I say this out loud. Let's see. I want a hotkey for ground. Nope, you can't set one. It would just be nice to have a hotkey for ground since it's just like the most common thing. Like every circuit's going to have it. All right, and then we'll copy and paste this symbol. I'm going to try and keep it in line. Draw a wire to there, and then we will rename this to be P12. P1. All right, and then that all was supposed to connect. James. All right, so select all of this. We're going to move this down because it was supposed to go off of pin 1. So did I have a 68K? I did. Let's put this one here and this one here. And then highlight, and we're going to move all of this to here. This one is P. Oh, good call. Thank you. Did I get the other one correct? Okay, yeah, I see what I did. All right, good call. All right. I am going to do, let's see, we may actually end up drawing this, even though okay, we may end up drawing that because that's so on the back of a CRT, there's a little board that plugs into the back of the tube. I'm pretty sure that's what it's in this schematic, and this is the analog board, but they're basically saying there's this other board that has like a couple of filter components on it. I think it's filtering. I'm not sure what else it would be. That is wrong. Move this over here. Move this over here. Highlight to here. There we go. And then this will connect to here. There we go. Okay, so this is R7 and R8, and they're both 68K, which I've already taken care of. R8, R7, R. I'm going to X to put them over here, but I'm going to move these to be a little closer. I know very little about the PDP-11. That's not a computer that I ever really encountered. I would like to learn more about it, but I don't have a context for it. Like I'm trying to think when I went to college. So I went to college at Purdue, and The computing center may have had one that was still in basically the operations center. I think we just called it ops. But I don't think it was functional. Or if it was like, maybe there was like one class that used it or something. For some reason, I just feel like I remember, because I was really good friends with one of the admins. And I remember he would tell me about some of the, like, one of the reasons he had his job was he would manage the systems that nobody else wanted to deal with. He was like the super nerd. When you think computer nerd, it was this guy. But he was super nice. I really liked hanging out with him. Incredibly intelligent. In fact, he ended up going and doing something that required a security clearance. And I remember having to do the security interview, like an FBI agent went and interviewed people he worked with. And so, like, I remember sitting down with this FBI agent. I kept his business card for the longest time just because I thought it was so cool. I was like, I have an FBI business card. But then it turns out that was like the one of 3 times I got one of those cards. The 2 other times where it was literally one of my neighbors were getting their security clearance, and so they were just knocking on everybody's door to talk about the person. But in that guy's case, he was actually one of the references that he gave me as a reference. And I felt really bad because he asked some questions that I was just like, oh, I don't want to talk about him in that regard. It's like, come on. I didn't see it. Well, I guess no, in case I ever give too many clues like I did like 30 seconds ago. I'll just leave it at that. Moving on. I actually had another friend that worked in the computing center. She did, see, I'm giving away clues right there. Or am I? She did an internship at the CIA, and that was like the big game that we always try to play was try to figure out what she did while she was there. She wouldn't tell us anything about what she did. Now, in her case, I don't think she had a clearance. And so I don't think anything she would have worked on would have been top secret, but she still didn't like to talk about it. But I might be wrong about that. I don't remember. It's been more than a few years. Was it Mulder or Scully? It was the guy I talked to was much more of a Mulder. He was about the same age, kind of same build, but nowhere near as interesting. Well, there's a name I haven't seen in forever. How you doing, Yasser? Unless I've got you confused with somebody else, I remember you coming to live streams before. And if you're new, then welcome. Just in case, let me cover all the bases. Welcome back or hello. Welcome or welcome back. All right, let's hit O to reset this one. I'm going to move this down to about here because I think we're going to need the room. I wonder if there is a property that will allow me to tighten up the space between the symbol and the reference values. I don't see anything. Oh well. Because I would really like, and I'm not sure I understand why they're so far away. Maybe it's a readability thing, but I'd really like a way to change. I wonder if there's a property I can change. Formatting, text size default, overbar, off rate, label offset. Global margin, global label. Dash lines, darn. Yeah, I don't see anything. Because I don't think this is going to change the way I want. Yeah, bummer. Hey, Pete. The secure phone system. don't know, imagine how does the Pentagon have a discussion about what is a secure phone system? And then it's like, but we can still listen, right? It's like, yes, this is totally secure and we can still listen in on it. Like, wait, what? It almost feels like a Monty Python sketch or something like that. It's like, is this secure? Yes. Can you still listen in on our conversations? Yes. It's like, then that's not secure, is it? Yes. All right, before I get away from here, R8 68K, R7 68K, C3 100 nano 100 volts, C4 100 nano 100 volts, R5 470, and then ground. Okay, so that section looks right. I started getting more chatty, so I wanted to make sure I hadn't missed something. All right, let's do R3. 150K. Oh, you look for that too, RJ? Yeah, I feel like there should. It's really bugging me because I feel like there should be something that lets you define it. I don't want to spend a lot of time because it's kind of silly to do that right now. But it just feels like, oh, I didn't know you could change the orientation repeated items. Can you make this a negative number?
There was much rejoicing.
Yay. Yay. So, okay, and then I wonder, hold on, let's try one more thing real quick. It's kind of cumbersome, but no. So if we said D7, oh, wait. So I'd have to come in here and can you change the increment to be a negative number? So let's do label D7. Oh, look at that. I don't know when that got changed, but so that's the insert key. So when you press, so insert repeats the last command. And I don't remember being able to change these options before. And so it meant if you're doing like an address bus and you need it to get, and you need it to go 15 down to 0, you would do A5, or you'd have to do A0 and then insert this a bunch of times, highlight it and reverse it, which is probably still the easier, faster method. But it's just nice to know that there is an option somewhere to change the way that things get auto incremented. Hey, Heartfruit, welcome to the stream. In case they forgot to turn on the scrambler. Oh, could you imagine that? I just got the secure line installed and then somebody comes in or you get a memo that says, by the way, you're not using your scrambler. You're like, wait a minute, how do you know? Net classes, how to make these net classes in Schematic, and it's updated on the PCB side. So net classes are already synced between PCB and Schematic. However, the thing that gets missed is where's it at? So if you go, so in Schematic, I'm going to go into Schematic setup, into net classes. What time is it? So I'm going to go try and find that in the archive and see if I can figure out how the crash occurred. What is the last backup? It's been a long time since I hit save. I'll come back to the net class thing in just a second. Okay, it's got autosave files. Do you wish to restore? Yes. We had this whole section done. Okay. So So what I was going to say is, so if you go into schematic setup and then in PCB and board setup, there are net classes defined. And the thing is you can come in here and you can create whatever you want, right? You can create your net classes, whatever. And then, so like if I click OK and then I hit F8, and then we're going to get a boatload of errors. Okay, never mind. In PCB, when you look at net classes, I guess I could have just actually gone in here because this gets saved by the project file. In constraint, what am I looking for? I totally net classes. These are the same net classes, right? The thing is, though, is like, well, how do you set all this stuff? Like, it'd be annoying to go back and forth. However, what is not apparent is if you go back into schematic and we go back to net classes, if you want to manage all the net class stuff in one place, all you need to do is right click on the columns and add things like the track width and the via size and whatever. And then you can set whatever you want in here, because net classes are saved at the project level. So now if we go and open up the PCB, I made the default be 12. Now I'm going to go open up PCB. And my track width for the default is changed. And then you can also have color and line style and thickness and stuff from schematic in here. Although I'm pretty sure like color in here in PCB has no effect. It's the color for schematic. I don't think you can do per net class colors in PCB. I could be wrong, but I'm pretty sure that doesn't work. It's just allowing you to basically modify the entire net class parameters in either program. It's just that the default columns are the ones that make sense for the particular program. So, all right. There we go. 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 Okay, let's try this again. That's cool. That's okay. I wanted to redo some of this stuff anyway. All right, so we're going to put that here. This is going to come down here. And then I'm going to put that one here and this one here. And we're going to call that one C3. Yeah, that type of crash is really frustrating because I don't feel like I did anything out of the ordinary. And so it's really difficult to file a bug report because it's like I don't know what to do. But what I want to do is I want to go back in the VOD and see if I could recreate a series of steps, because I think it's something to do with changing the preferences that mess it up, that cause the crash, because I feel like that's been a reoccurring thing. I just haven't been able to duplicate it for the purpose of a bug report. And the thing is, if you're not familiar with the KiCad development team, they're really good about getting, like, if you can give them a good bug report, they're pretty good about getting them fixed in a fairly timely manner. Certainly much better than a commercial vendor. Is there a save function? Is there a save on change function? No, I don't think so. I think you could change, like, I think you might be able to change the autosave interval, but that's about it. I'm running 801 from last week. I think last Thursday I had release candidate 2, and then I think Friday 801 came out, so I'm running 801. Is how the net assignment are synced. So it's actually the same thing. So if you have your net classes defined here, and then if I come in here and I'm going to label these to be like net 1, just so that we can actually see the names. And then I'm going to make this net 1, this net 1, and, well, shoot, you don't want to do that, do you? I want to make this net 2, and this be net 3. So if I do this, and then I go into my net class, and I say that I want those to be power, and I'm going to want their track width to be 100 mils. I'm just picking absolutely ridiculous numbers. And then down here, I'm going to say I want to match anything that is, darn. 03? What's the regex for numbers? Oh, I need a slash. There we go. Actually, this probably would have worked, right? Did I just do net 1 and 2? That's weird. Okay, whatever. So if I do that, and then it's sort of the same thing. If I go and look at PCB, and maybe you're just saying you're refining your question, and now I'm over-explaining, but just to demonstrate one more time. If I go into net class setup here, oh, in this case, they're not showing. Okay, shoot. All right, you know what? Never mind. I believe they're supposed to sync between them. It's not syncing right now because I have to do F8 to bring the nets into PCB so that PCB knows what the nets are. There was a bug. Oh, that's not what I meant to do. There was a bug where I did run into a problem with. Never mind. I don't want to explain. But where I'm going with that is the reason it's not matching in that case is because I haven't imported the nets. I can't import the nets because I can't. It's the reasons. I really hope that answers the question. The reality is net class assignments are synced between PCB and Schematic now. I believe that's new to 8. I don't think that was in 7. I could be wrong about that though. I don't know. I don't remember for sure. And if that still doesn't address the question you had, then let me know offline, I guess. I want to move on. R potentiometer small. Let's do an X and bring that over here. And then we'll do a wire. This will be R4. Let me close the property panel because, again, that's messing things up. And then I'm going to remember to, actually, since we brought it up, I'm going to see what the autosave, I thought there was a, maybe it's just automatic backups. That might be the only, autosave every 10 minutes. I'm going to actually say every 3 minutes. It's going to get kind of ridiculous, but I would rather it be a little more off. I don't want to go 1 minute because that's way too fast. But I do want to, because I keep running, I don't want to keep redoing stuff. Regex does not work on everything, but it does work on net class assignments, which to me it's good, it's nice, it's powerful. But I don't think it's very clear to people that that's how the net class matching works, which is actually a video topic that I have on my list, because I think the whole net class assignment thing, I have vocally talked about, been very vocal about how unintuitive it is. However, now that I realize it's actually just a regex match, it's very powerful. But I don't think it's clear to people that's what's going on. And that to me is the thing that can be improved. All right, let's move this over here. Let's kind of do one of these. Let's do this. Yeah, so I've got, I haven't, so I do know, so I've got, let's see, so yesterday was the Apple II / MXO video. I do have one more MXO video that I want to do, which is going to be very targeted towards people that are actually in the market for the scope, but I think it'll still be interesting to see. It'll still be an interesting video, even if you're not looking to buy one, just because I want to get into what's the difference between the Rohde & Schwarz's previous generation, the 4, and the new one, the 5. But that's going to come out like at the end of April. The next video I'm working on is a KiCad. I'm going to do another KiCad tips video, and that one's going to be tips on how to arrange parts in PCB. So like once you go to PCB and you just drop all the parts into the very first time you do update to PCB, the parts just get dropped as a big blob. There's a couple of things you can do that actually make managing that blob super easy and kind of quick. And so that'll be a tips video on how to manage that. And then I was going somewhere with this. Yeah, because I'm trying to get into this. I'm trying to get into this cadence of I want to do like a Apple II measurements video, a KiCad video, and a review video, and kind of like go into a cadence like that. Because like I've got a couple of things that are lined up for reviews that are supposed to be coming in. Well, I'm not gonna plan anything around them until they show up, because that kind of stuff tends to, vendors get really excited and they're like, oh yeah, we're gonna send it to you today, and then like 3 months later they still haven't finished it yet. Yeah, I think I really wanted to do the managing the parts thing a long time ago, and then I have it scripted out, and I even did some screen captures for it. And then versions, to give you an idea how long it's been sitting in the draft folder, then version 7 came out, and I was like, oh, I better see if there's anything new here, and then I forgot. So I do want to get it done though, because I think version 9 may go back to having a bunch of PCB stuff in it. And if so, I want to make sure we get that covered. But I don't know. It's just it's one of those things where it's like pack and go is the most useful feature, and then there's some ways you can change cross probing. There's also a couple of hotkeys that you can use while you're in PCB to like I think it's either T or Shift T. The T isn't like Tom. You hit that, and then you type the designator, so like C11. And then what will happen is wherever your cursor is, C11 will snap to it. So like if you had your PCB and your schematic next to each other, and you're like, oh, I need this decoupling capacitor, you could do like T, C11, and then it'll snap to where you're at, and then that way you can place it really quickly. You know, and like just little things like that, it saves a ton of time, and it really helps to deal with like decoupling caps are probably the biggest thing, the hardest thing to manage, is like how do you get those back? All right, so this looks like another element of U1. So let's come up here. And that's going to be probably the C unit. Yeah. And then that one, what I'm hoping for is to get like people to, like in the comments, will hopefully post what they do to manage parts, because I think there's a bunch of tricks around that. I just think there's lots of things you can do. Ultimately what I'm trying to address is how there's a lot of new users that will come in and they kind of get upset, and they're like, well, why doesn't KiCad just group all of the schematic stuff with the same way in PCB? And there was a plugin for a while. I don't know if it stopped working with 6, I think. There's ways to sort of do that, but I think it's actually not an intuitive way to handle it. It would be kind of nice if you could just anyway, I'm just babbling now. Yeah, that was your question. Okay. I'm glad I was able to answer it. I totally missed that, Yasser. Well, so the KiCad team is on a yearly cadence, and version 8 came out last month. So 9 won't come out until sometime next year. Like you can go download a nightly of 9 right now. As soon as 8.0 released, the nightlies became 8.99, which is the nightlies for 9.0. But yeah, it'll be at least a year away. And my suspicion, I'm just based on some of the features that they talked about, my suspicion is it's going to probably come out, it's probably going to be closer to an 18-month release than 12 months after 8. Because starting with version 6, the development team was trying to stay on a yearly release schedule, and they've been like on a 12 to 14 month release schedule for 6, 7, and 8. But I feel like there's a couple of things they've talked about doing in 9 that I just have a feeling they're going to get extended. That said, it's actually amazing that there's already a thread on the KiCad forum of like the development team, when they introduce a new feature, they post it on that thread. And like days after 8.0 came out, they started filling up the the KiCad 9 thread. I just thought that was hilarious. It's like, yeah, it's such a change from the commercial EDA tools, where it's like, you know, Eagle's big innovation was they created new icons that had more colors or something, and then I guess they might have added some features, and then they did the whole Autodesk thing, or the Fusion thing, which, love or hate, it's a thing, right? And while I'm not trying to say KiCad is not without its flaws, there's definitely some things it doesn't do well, and there are things that I wish it did. But the rate at which it gets improved is vastly superior to almost every other EDA. Like, there isn't a comparison. Now, keep in mind, that's actually kind of I don't know what you call it, straw man argument, false dichotomy. The trade-off to that is KiCad is also, like, if you say relative to Altium, is really behind in a lot of areas. And so, yes, they have these big steps forward in terms of usability, but it's because they're implementing things that everybody else already does. And I'm not trying to knock anything that anyone on the team is doing, because that's still very significant. But let's be frank, that's part of why they're able to make such big steps forward, because they're implementing things that people have wanted for a long time. So, yeah, I'll leave it at that. Sprint layout added. Well, nothing. Yeah, actually, does that even still exist? How often does Blender update? I mean, I imagine Blender's got to be an absolute nightmare to keep up with, just because there's so many modules and things that it does. I can't imagine that, like, I really don't know. I just feel like, or is Blender one of those that when you load it up, every time you load it, it updates all of its modules and stuff, and so it's like it's a constant update thing? And it's been a long time since I loaded Blender. I was learning how to use it, and then I stopped. Wait. Sprint lost the feature. That's kind of funny. It's like, well, we fired this guy, or this guy retired, and now we can't do any more updates. Which totally sounds like a legit thing that could have happened that I made up. Let's see, dash line. Let's see, items shown with dash lines are located off the board and shown for reference only. Yeah, okay. I'm not going to worry about that note. Okay. So I probably could make a connector, but I'm not going to, because this isn't really drawn as a connector. So here's what we're going to do. I want P4 1, and then I'm going to do insert to get 1, 2, 3. Whoa. What are you doing? Why are you doing that wrong? Did I mess up the preference? Let me save this before I go to preferences. I messed up something. I broke something. What did I broke? What did I break? Preferences, not paths. Vertical pitch 100. Okay. So if I do add part con offboard single, I'm going to put it here. I'm going to edit this and make this P4-2, and then move this, which I think I can do. And now I should be able to insert, oh, what the hell? All right, whatever. I wonder why it's not working. I must not have drawn these correctly because they're not lining up. All right, I'm going to get rid of this preference for a moment. Clicking on pin selects the symbol. So I'm going to enable that preference so that I can move these quickly. Otherwise, we're going to be here all night. All right, so then let's move this so that everything's lined up nice and neat. So this is going to be 9. I'm still confused why my insert trick didn't work. But that's okay. We're just going to move on. All right. So I've got 1, 2, 3, 4, 5, or 6 and 7 somewhere else. 6, 7. Oh, wow. There's a bunch more. All right. All right, we'll do 6 and 7 for the moment. I'm going to move those somewhere else. The last version's lost on a USB stick. Yeah. So Blender does do LTS. Okay. I guess you could argue, I don't know. Is KiCad, could you consider the major releases? Probably not. It's not really the same, but yeah. Well, and remember, we're doing in this schematic, we are doing an analog or the analog board for CRT. So a lot of this is dealing with either high current or high voltage or both. And so it's not the more or less it's not like a very typical design. Like I think this connector is a massive Molex style connector. Even though Molex is a company and they make lots of products, but if you look at it, you're going to call it a Molex part. And so it's like, could I draw it as a connector? Probably, but I like how they've done it here because it makes it like, even when you look at the board, it's going to be very obvious where all of these signals are at. So, especially since it's probably a single layer board. I think it's a one-sided board. At least the analog one is. All right. If I do insert, nope, that's not going to work either. But copy paste does. That was actually the last I just realized the last live stream I did in the lab was last year Macintosh, when I started recapping a Mac. Like if you remember, if anyone was here for that, I have a Macintosh Classic that when I picked it up, I could hear something rolling around inside. And when we opened it up, it was the battery. And like the entire board is destroyed. There's like, people have asked me if I was going to try to repair it or like replace it with there's like somebody recreated the PCB for the Classic. And it's like, there's nothing left. There's like no reason to do it. I'm like, yeah, no. So, I don't use Death by Varda. Yeah, exactly. That one is, because I think what happened on that one, I think it was in a storage unit, and I think it got wet. And so I think the combination of water and battery acid just caused it to, although, should we actually call it battery base? Oh wait, well that's lithium. I don't know is lithium acidic or is it basic? Because alkaline is basic, right? But we call it battery acid, even though it's anyway. Anyway, it was super bad. Like just I've never seen one. I personally have never seen one as bad as what that was. That said, there are definitely worse out there, but so I'm going to label this now, but we're going to get a complaint from ERC later, and I don't really care. We'll just deal with it later. Because I do want to have these labeled the way that they've got it here. So then I'm going to copy. Whoa, what did you do that for? I'm sorry, I don't remember if I answered this. Do I use FreeCAD? No, I don't. So I'm not a big fan of FreeCAD yet. It's, for me, it's not there. I use Fusion. So even though I knocked it earlier for the Eagle integration as a mechanical CAD tool and as a CAM for my CNC, I find it to be quite usable. So, which I completely understand if somebody doesn't like it. Like, I'm not going to try to justify and say FreeCAD versus Fusion. It's just that I believe in use the tool that works best for you. So like in the case of KiCad, I just don't, there's no commercial ECAD program that works better than KiCad for what I do. And so that's why I use it, right? And I want to be careful about that because, you know, like if you're doing like RF boards, this may not be an ideal tool in some cases. Like I think there's lots of things you can still do with it, but it's not necessarily the best tool. So, you know what? I just realized these should just be 5 volt. I really wish the property editor worked. It's so frustrating to have to wait for these windows to open up. Also, let's save. Yeah, alkaline's just as corrosive. Thanks for saying that. I didn't say that out loud, but yeah, that's actually, it's just as so. And I think we sometimes forget that a basic solution is just as deadly as an acidic solution, or as dangerous, right? Most people tend to think, oh, acid's good, base isn't. And it's like, no. And leaking batteries are a great example. It's like, yes, alkaline batteries leak a base solution or basic solution, and they destroy boards. They can destroy stuff. So, but yeah, you're right. I'll yeah. Anyway, it doesn't matter. As our friend Josh would say, take your batteries out. Take your batteries out. Take your batteries out. Take your batteries out. Like, just take the battery out. Like, even on my TRS 100, I don't know if TRS 80 Model 100, the portable computer, I don't know if anyone was here when we repaired that. Even though I keep batteries in it, but I don't keep batteries in its disk drive because I don't know the next time I'll ever use that. But the batteries I do keep in my TRS 80 100 are rechargeable, and once a month I swap them out with a fresh set. So I'm constantly moving them. But like if I was to ever, and it sits right next to my battery charger, but if I ever move it away from that battery charger, I am absolutely taking the batteries out. So yeah, hey Thomas, or is it Thomas or Tomas? It's a shame that FreeCAD doesn't have a big cache injection like KiCad. Totally agree. Totally agree. It's really what it needs. It really needs just, yeah. I'm trying to think if there's another way to re-say what you said, but you said it correct. I mean, that's exactly where it's at. So it's kind of a shame, you know, it comes down to, it's all about money, but at the end of the day, everything's about money. Right. And yeah. And you know, by the way, I always also feel this way. So I didn't last year because of a reason. I forgot. But for the last several years, and I've already done it this year, I always donate money to the KiCad Foundation because I feel like I get plenty of value out of KiCad that I should, financially support the project, and if you're able, and I'm able to. But just to reiterate something I said earlier, because I really do believe this, I don't use KiCad just because it's free. I use it because it works really, really well, right? And that's where I'm trying to articulate my feeling about FreeCAD is, if FreeCAD was a better tool for me, I would use it, but it's not a good tool for me. And so it's kind of a chicken and egg thing, right? I'm not going to donate to the project until it works well for me, but they need cash to make it work better. I have to think about that. Didn't really. That's a conundrum. Lithium can be both acidic and basic. Does it depend on? I guess lithium's a metal, right? Well, yeah, because there's no alkaline is not a metal. Lithium is an actual metal. Okay, yeah, I see. In this, so Hardfeld, are you setting all the symbols to passive? No. In this connector, these are set to passive because these are meant to indicate an off-board connector, which in a CRT, it's really common to see these where there's like these, like they look like heavy-duty DuPont or header pin connections. There's like a piece of metal and then something gets shoved onto it. And it's really built that way for repairability, so you can disconnect the high voltage stuff and pull it out. And so this symbol I created, these are set to passive because they are technically a connector, and connectors should be set to passive. But like in this symbol for the deflection controller that we created, if we go look at its definition, I use the data sheet to make sure we set, at a minimum, I like to set the power and the inputs and outputs. And so if there's pins that I'm not entirely sure how to handle, I'll make them passive or undefined. But for ICs, I try to set the pins correctly. So long answer to that question. Yes and no. Yes, no, and sometimes. Okay. All right. So where are we at? So I got, that looks like 1B, and then horizontal drive comes somewhere around here. So let's start doing this one. This is another part of this gate. This may not be low enough. Where's this in the overall schematic on this one? Because I think there's a whole boatload of crap to its right. Yeah, there is. We're going to need a bigger sheet. All right, so let's highlight all this, and let's just move this all down to about here. Oh, I forgot to add a text thing here. Height. What's going on? Oh, Control Enter. And then let's do a polygon. There we go. That's much better. Actually, Pete, I noticed that about FreeCAD is like, compared to the last time I tried to legitimately use it for something, I tried it recently and I was like, okay, a bunch of stuff has changed and it's not clear to me why things are different. Like it doesn't feel as cohesive as KiCad, which could also come down to money and resources, because maybe they don't, like, KiCad has a very good structure, a very structured team for making changes. It's like it's really difficult for a random person to come along and alter the path of the project. But yeah, that was something I noticed. It was just like, it was definitely had a lot more capability than the previous time I had used it, but it was also not improved in a good way for how I use it. Not because, like, I'm trying to be careful, because like my buddy Clem from Myers Makes, he uses FreeCAD, I think, exclusively, and he has, from what I can tell, very few issues with it, or at least he's able to get what he needs done. I'll put it that way. Maybe that's a better way to describe it. Whereas when I try to use it, I get very frustrated and give up, which, in fairness, is how I felt about KiCad 4. I remember many times I was on the I would be trying to get a project done, and I would drop into the KiCad IRC channel and I'd ask like, how do you do this? And get told, oh, it doesn't work that way, or we haven't implemented it yet, or this is how you would do it in KiCad. And I'd just be like, whatever, this is stupid. I'm doing it in Eagle. You guys are dumb. Those are actual things I said one night, and I am embarrassed that I did, but I'm going to own it because I learned and moved on. All right, so I wanted to, so this BJT, it's a 2N4401, but I don't know what its pinout is. And even though it doesn't really matter for this schematic, I would like to have it correct. And so it looks like as a TO220, it would go emitter base collector. And the reason I wanted to know that is because if I look for Q underscore NPN, now I can look for, let's see, so it should go E for emitter, B for base, C for collector, so EBC. So there is a symbol for it. Now if I delete those, you can see there's a whole bunch. There's the base emitter collector and collector mace emitter. Anyway, you can see the other variations. So my only reason for doing this is because I just wanted to get the correct pinout variation. And then we'll go ahead and do this since we've got it in here. Might as well. We'll add the data sheet, and then I'm going to close that because I don't really need it. I'm not worried about finding that data sheet one day. And this looks like that will be Q1. Q101. Sprint layout and S-plan. Yeah, okay. Oh, the BCs do it the other way. Yeah, I could see that, Pete. I feel like so actually along those lines with these older parts, I'm more comfortable like identifying. Wait, that's the wrong symbol. Hold on. Let's do change symbol. Yep. Change this selected symbol to, I'm just going to do it this way. It should have been emitter base collector. I think I clicked on the wrong one. There we go. Yeah, 1, 2, 3, 4. 1, 2, 3. I'm more comfortable in these older schematics because I know that these were a pretty standardized layout for a long time. If I was to use a newer part today, I would definitely double check the pinout because I don't think. Well, I'll tell you, actually, okay, let me rephrase. There's the case I'm thinking of is actually a little bit different, but it's still a reason to double check it. A TO220 might be pinned emitter base collector, and that's 1, 2, 3, but an SOT23, the surface mount version, may have a different pinout. It may not be emitter base collector. It may actually, I'm trying to remember what it is, but it's like pins 2 and 3 are swapped. So it'll be like emitter collector base or something stupid like that. And it's really frustrating because you can't like have like the TO220 footprint right next to the SOT footprint and just kind of like lay them nice and clean out. It's very annoying. Yeah. So yeah. I mean, at one point, JDEC was, I mean, they held a lot of power, and that might actually be an interesting thing to, well, I don't know how interesting it'd be, but I would be curious, like, where did all of their power influence come from, and where did it go? Was it some guy named Cotton Eye Joe? That was dumb. That was so dumb. Why did I say that out loud? Anyway. Because like I feel like today JDEC about the only thing they really control is the pinout for DRAMs. Like, because you look at just about any other component other than DRAMs, and nobody's following any pseudo standard anymore. It's so frustrating. We lost our symbol up here. What was our designator? What was comp, the signal? No, yeah, out of the comp out of pin 11, C6. And that was a 100 nano, not mic. What in the world? Oh, okay, that's C7. Wait, something's wrong. This isn't right. Hold on. For this, there should not be a connection here. Because it should be R9, R10, C7. Okay. Got it. Sanity to EEPROMs. Oh my god, EEPROMs make me so irrationally angry. I cannot believe the industry let EEPROMs be as messed up as they were. Like, I just cannot understand how, like, I don't know. I'm not trying to give them God status, but I can't imagine how, like, an engineer like Wozniak was like, oh yeah, I'm okay with the way that these EEPROMs are defined. Like, how did he not just constantly yell at vendors and be like, make this pinout sane? Like, what? I can't believe nobody did. Like, why didn't anybody just say, you know what? We are going to make it so that I'm just gonna move on. I can't read what this cap is. I may have to go and look at a real board because I can't read this. Where'd it go? So C11, it looks like 33 microfarads, but that number sounds funny to me. Because this definitely looks like 39 ohms, which isn't as strange. $5 watts. Watson, would you come in here, please? And it feels like they want this to be a bleed resistor. So I wonder if this is a different value. That really looks like that's supposed to be 400 volts. Okay, I'm putting a note here. Verify C10 V rating. Let's make this orange. And then down here, verify C11 cap. And let's make that orange. Like that actually, we should be able to look at a real board and determine what those are supposed to be. What's the difference between a convention and a standard? A standard is written down. I mean, conventions are, like, for example, my favorite super popular convention is that the long leg of an LED is the cathode. That's not a standard. That's just what a lot of vendors do. I've bought short-legged cathode LEDs before. A standard, there is a organization or a body that has written down, here's what, in order to call your thing this thing, it must conform to these specs. And so, like, JEDEC has definitions for, I'm just use an example like a DRAM. And so, yes, you can make a DRAM chip that does not conform to the JEDEC pinout, but then you can't tell people it's a JEDEC compatible DRAM because you're not following their standard. And then there's other standards, like the military has a whole slew of stuff. Like, you'll hear mil-spec, but there's also mil-spec is really, I can't remember what mil-spec actually is, but like for passive components, there's the mil-pref, the MIL-PRF drawings, which each each of those has a drawing number, and then the drawing number corresponds to certain parts. There's also DLA drawings now, which I think supersede PRF. Yeah, anyway, so standards are something somebody wrote, like a body of people wrote down. A convention is just, this is how we all do it. Like another good example is labeling the cathode of a capacitor. I could be wrong. I'm pretty sure there isn't a standard that says to do that. That's just the convention that most people use. Now, that said, that only applies to aluminum electrolytic capacitors and aluminum polymer capacitors. Tantalum capacitors mark their anode, not the cathode, for reasons. By the way, on the LED thing, I sincerely mean this. Always check your LED with a DMM. Put it into diode mode. It probably won't be able to measure the forward voltage, but it will at least light up the LED in the correct orientation. Always check with a DMM. When I was teaching electronics classes at Tech Shop, one of the classes I taught was measurement class. And so I would show how to use a DMM, a bench power supply, and briefly go over how to use an oscilloscope. We didn't really have enough time in the class, but I tried to at least show people to like how to use the auto set button to get something on the screen. But so for the DMM, I would give them a capacitor, because the ones we had could measure capacitance. I'd give them a polarized, non-polarized capacitor, a couple of resistors, and LEDs. I don't remember now. I don't think I used regular diodes, just because it's the same as an LED in terms of test. And I would hold up the resistor and I'd ask people, what value is this resistor? And people would start like looking at it, and then usually somebody in the class would know the resistor color code, and I'd be like, guys, you have a test tool to measure the resistor. Just measure it. Yeah, it's good to know the resistor color code, and it's not a bad idea to double check, but it was a trick question. It's like, there's no reason to look at the resistor's color code because you have a DMM to do that for you. But it was funny because everybody wanted to do the color code. And the reason I did that is because then we would get to the LED and I would ask, which one is the anode and which one is the cathode? And everybody would say the long end or the short end or whichever it is, because I don't even remember. And the thing is, before the class, I cut all of the LEDs so that they were that the lengths were wrong, right? And again, I would make the point. It's like, you have a test tool. Let's use that instead of a convention. Resistor color code, I think, is actually a convention, although there may be a JEDEC standard for the colors. That might actually have a standard. Is this a ferrite? Yeah. Do we have an L ferrite small? Sorry, that was a lot of words. Eight-pin dual amp, probably. Op amps are, I feel like that's a whole nother list of. There's just so many variations of so many similar parts that I feel like op amps would be one of those kinds of parts that somebody might go to like a TI and say, hey, we need 1 million of this op amp with this pinout for some reason. And so they would create it and then sell it as a standard part because they've already done all the tooling for it. And it would just be like a package variation or something, or it'd be like the TL045-3 or something, right? That's a kind of part that I could just see like a non-standard pinout getting created just because somebody bought it for some other reason. On the other hand, the benefit of having a standardized pinout is it would make designing in different types of op amps really easy, right? That would be like a really big benefit, is these 3 op amps will work fine, or somebody comes out with a new version of an op amp that has lower noise or better offset or something, and it's like, hey, I can just drop this in, it'll work fine. But I would argue the same thing with, never mind. All buffers and inverters should have cross-flow pinouts. Oh my God. I think that's actually why I don't like using the 74 244. I can't remember, but I feel like there was a buffer that I was using for a while, and it has a terrible pinout. And like I think it's the 244. Like I use the 245, even though it's really only available in the wider package, even though there is some stock out there of the smaller package, surface mount. But it, other than the enable pin, it's a very clean layout. Like it's input, output, or, cause it's bidirectional. But it's like, I think the 244, or there's a unidirectional version that is not. It's like in out instead of in out, which I don't understand why you would do it that way. That makes no sense to me. Zero, zilch. But then again, maybe that was same kind of idea. It was like some customer at some point said, hey, TI, make us a part that looks like this. And TI's like, okay, we're going to sell it to everyone for some reason. Yeah, if the op amp goes obsolete, that's a whole nother one. Maybe it's the 240 and 241. Hey, Squire. 541. Yeah. There's. I don't know. I don't want to get sidetracked. I pretty much at this point, the 2 buffers I like are the 245 because it's bidirectional. So even if you don't need it to be bidirectional, it's like, okay, it works fine. And then the 573, although that's a transparent latch. And then there's one other one that I want to find. I'm trying to think why the transparent latch I don't like. But yeah, I want to say the 244 is, there's something about it that it just irritates me. And so I don't use it anymore. Like I think I have like 20 of them left over that I haven't, that's not going to be connected, that I need to get, I won't be able to, well, I'll use them eventually, but okay, Q2, let's get that in here and then we'll see where we're at. Because I think I'd like to get to a point where what's left is creating the transformers. I don't think we're going to get to that tonight. That is not one of my more favored activities. Is that a BU406 maybe? Yeah, that seems like that's what it could be. Oh, we can click on this one now. Aw, come on. Hey, if you're going to pay to have your search result be on the top of the page, I am going to make sure you pay for it. I have no problem doing that. Okay, so what are we looking at? So this one's going to be emitter collector. 1, 2, 3. Oh, I see, with a tab. Okay, so we're just going to do emitter collector. I wonder. So we need a Q in PNP, and I want it to be base collector emitter. Or is there a base? Oh, yeah, that's actually what I want. Base collector emitter collector. Even though that's not what's drawn in this schematic, we'll make it correct. We're going to do it right anyway. And that's going to be its base resistor, 500 series or 200 series with better pinouts. Really? That's something I've never actually spent a lot of time trying to figure out is what are the various groupings of this. I'll just call it 7400 series. I know a couple of them, but I don't really know why there's like, what do you call it? Yeah, I'm struggling to think of what I'm trying to think of. So we're using KiCad to create the schematics. It's an open source electronic design tool. It's primarily used for PCB design, but we're using it to recreate schematics for vintage computers, which goes into a repository called BitPreserve, which should be pinned to the top of chat. All right. And then these are going to go to, here. We're just going to do this for now. Ah, that's not what I wanted. Let's go G. No, what did I just do? G like that. There we go. That's pretty. All right. So 4700, 2200, MR 854, 28 microhenries, 100 ohms. We'll put a transformer here, and then that'll line up to R17, which will be in series with the other side of this transformer, and that'll go over here. All right. A 74. What is this one? Now I'm just kind of curious. I'll tell you what I miss is on the Twitch bot. It was like, I guess we never got part numbers to work. One of the things we had wanted to do on the Twitch bot was if you put in like a part number or like Octopart or something, it would like basically come back with an Octopart search. But Octopart wouldn't let us use our API because the application was technically a bot, but it wasn't a bot like what they define. Yeah, that's all. And that has Schmidt triggers built in. Oh, wow. That's nice. I'm going to save this. I wonder, is that still readily available today? I like that. And it's 10 inputs, right? 8. No. It's just 8. Why does it say it's a 10-bit? Are A and B included as bits? Okay. Shiny. Okay. Where are we at? Well, that's too far. Okay. Is an N type. Did I do a PMP? Oh, come on. James. Q NPN. Yeah. I don't even need to look. I already know. It's not a. I know what I did. In my head, I said NPN, and so I typed PN. P. Like, yeah, that was silly. You know what we should have done? Okay, never mind. I never labeled it. So where was this at? It's down here somewhere. So this is Q2, and it was a, what did we come up with? A BU406. I'm not going to link the datasheet because the datasheet link I found was on DigiKey, and I don't believe in linking to distributors for datasheets. I find it very frustrating that distributors, if I would actually link to a distributor, if they would link to the manufacturer's website, but a lot of people that haven't retired yet at distributors think that linking a PDF to another website will somehow cause somebody to leave their distributor site, go to the manufacturer, get the PDF, and then they may not come back, which makes no sense because everybody opens it in a new tab, downloads it, and then closes it. Like, anyway, I'm just grumpy. Okay. All right. Then there's a whole bunch of that stuff to do. All right. Yeah, LV and LVCs do actually seem pretty common. But yeah. Okay. This is super fun, but that's all I can get done tonight, which is unfortunate because I'm not going to get the power supply done next week, but next week we'll definitely be able to get the this analog board done, which would be great because then maybe it won't be for Macintosh, but maybe in April or May I'll be able to finally finish recapping my SEs. Because we basically have this section to do, which is basically my head, and then create those two transformers, and then just do those two parts. Oh, and then this section up here. Yeah, okay. This is a good stopping point. So I'm not going to try running. Well, you know what I will at least do is let's run let's see. If I try to run D or C, I want to know, gosh, this is where I wish I could I want to know what's not annotated. Let's get that done right now. So this is U1. I already know that. Well, I'm going to double check just in case I'm wrong. I thought I was wrong. Yep. Good thing I checked. That was U2. Input pin. Let's see. Not connected. That is the only thing that is not annotated, right? Unplaced units, we may not connect to it. Okay. The rest of those I'm not going to worry about yet because they're all because we're not done. But I think that will be good. Okay, RJ. The resistor color code was standardized by the Radio Manufacturers Association, RMA, which, was the predecessor to the EIA. And then EIA is now, or did RMA become the ECCA, and then the ECCA became EIA? Like EIA either became somebody else or they formed from something else, but it was something before RMA. That's actually kind of cool. I had a feeling that was standard, or like there was a standard for it, but not until 1963. Wow. You might talk to a TI rep about ordering your charge pump. Well, actually, the funny thing about that is TI, years ago, tried really hard to pull out of all distributors. And I think DigiKey was one where they realized if they were not in DigiKey that their parts would stop getting designed into stuff. But they were trying really hard to get out of distribution and just sell everything direct. And it's like, that's a dangerous thing to do. Okay, so EIA is actually what got, I couldn't remember if something morphed into them or if they turned into something else. So, because like when I was working with capacitors, the case codes were all EIA defined, but I remembered we also called them something else because it wasn't the only thing. All right, we need this file, and this file. I'm not going to commit anything else at the moment because some of the stuff shouldn't even be in here. Actually, let's do this. Let's stage that. And then that leaves FP info cache, which should be ignored. And then schematic back should be ignored. Sim table should be ignored. This we can actually remove. Will that delete? Yeah, because I don't need that anymore. I don't know what that's there for. This we're going to, how do I just do discard? Like, oh, I know why that one's there. Yeah. No, we're going to remove that. The C64 schematic needs to be updated to version, well, it's version 5 right now. You're just not getting done with work, Jack? Dude, that sucks. You didn't want to miss the live stream? I got bad news. All right, I'm wrapping up. I think so. Next week we'll definitely be able to finish the analog board, and then maybe we'll get the power supply done. Is this the last? Yeah. So what we'll probably do is we'll probably finish the analog board next week, and then depending on how long that takes, maybe we'll start the power supply. But what I would probably like to do, well, you know what? No, I think what we're going to do is we're going to finish the power supply, even though it'll be outside of March, because I want to get the analog board and the power supply done, go back and finish the MC10, and then figure out what we do from there. So interesting. So if you guys did not know, there is a new Atoms video out, which I think is really silly that I can't just point people to it. I think it's YouTube A2 clock. I don't even know what it is. But yeah, so it came out yesterday. It's measuring stuff on the it's measuring the stretch pulse of an Apple II clock, which was something that I was, well, we were working on the Mega 2 project. I kept like saying, oh, that's there for video. That's there for video. And I never actually understood what it did or how it, like why it was needed. And so in this video, I show why it's needed and how you can measure it. Now, granted, I did use a fairly expensive oscilloscope to measure it, but you get the point. You at least get to see how it works. So, all right, it's been fun. Thanks for hanging out with me tonight. Appreciate it. I'll be back next week. We'll get this analog board finished up, which will be great because, like I said, I've got some Macintosh SEs that I still need to finish recapping, and then yeah, that'll be fun. So thanks for hanging out, all that good stuff. Let's do, in case you're not already there is a Discord, and yeah, I look forward to seeing all of you next week, same time. Whatever time you're at right now. I start 2.5 hours ago. So, all right, try to have fun, do something that you enjoy doing. And if you do, please make sure you share it with other people. Take care, guys. See you later. Bye.